Hello, my name is Ilkin Jabbar Ali, and today I will be briefly talking about the basic concepts of fluids. In other words, I'll be discussing pressure and the Pascal's principle with you guys. Okay, let's say that we have this container here with one side of an area greater than the other side. We'll label the first area as A1 and the second area as A2. Now let's say that we fill this container with some type of liquid, and remember that the liquid here is incompressible. Let's just line this up. Alright, and let's say we have this liquid inside this container. Alright, so let's try to find some rules that are related to this concept of fluids based off of this container here. From the previous units, we know that the work equals to force times distance. So let's just write it here, work equals force times distance. Other than that, we know that we also know that the work put in the system equals to the work put out of the system. So we can write it as work in equals to work out. From the conservation of energy theorem, we know that the work in is the energy that you're putting in the system, measured in joules, and the work out is the energy that comes out of the system, measured work out of the system, meaning that no energy is destroyed nor created. So from this right here, we can say that the force put in the system, force in times distance in, equals to force out times distance out. Okay, so imagine if I apply a force on this liquid on one end of the container with a piston. So let's just draw the piston here. Okay. I apply a force of F1 here. And let's say the distance that the piston pushes the liquid is D1. I'll just label it here. Okay. So we know that the volume displaced here equals to the distance pushed times the area on that side. So we can say that the volume displaced, or VD, equals to the distance on that side, here in this case D1, times the area on that side, so A1. But since the liquid is incompressible, we know that it has to come out of somewhere else. So all the volume displaced needs to go out from somewhere else. So we can identify that the liquid will arise to some level on the other side, and we will label this and we will label the distance that it will arise as D2. So this is the distance that will arise. The volume that you're pushing here, is the same volume that goes up on the other side. So it's the same here. The volume that will arise can be written as V2 equals to distance 2 times area 2. Since both volumes here are equal, we can say that the distance 1 times A1 equals to distance 2 times A2, or area 2. And remember, since we are applying a force in one end, the force will push out of the other end. So let's just label the output force as force 2, or F2. F2. Just like stated before, the input force times the input distance equals the output force times the output distance. So let's just rewrite this initial equation as F1 times D1 equals to F2 times D2. Instead of stating input and output, I just put 1 and 2 for simplicity. Okay, since the area plays a crucial role while pressing the piston in the container, let's just rewrite the initial equation and add area to it. We can say that the force input, or the F1, divided by A1, and we can multiply this by area 1 times distance 1. As you can see, I multiplied and divided the area, which you can do with any variable or number. So F1 divided by A1 times A1 times distance 1 will equal to force 2 divided by area 2 times area 2 times distance 2. This part of the formula where it says that force 1, or force input, divided by the area 1 is actually equal to pressure, and we can label this as pressure 1. And from the previous formulas here, we can say that the distance 1 times area 1 is equal to volume, so we can rewrite this as volume 1. And the same thing is considered to the other side. Force 2, or the force output, divided by the area equals to pressure, and we can label this as pressure 2 times volume 2, and the volume that's displaced on the other side. And just like stated before, we can say that the input volume equals to the output volume. If we divide both sides by the volume, let me just rewrite this. Divide both sides of the volume, we can get that pressure 1 equals to pressure 2, or the pressure input equals to the pressure output. Alright, so in conclusion, this shows or proves that when there's any external pressure applied onto an incompressible fluid, that the pressure is redistributed evenly throughout the liquid. And we prove this by using the law of conservation of energy right here. This is also the Pascal's principle, which states that if any external pressure is applied to a fluid, that pressure is redistributed throughout the liquid equally. This is it, and thank you so much for listening. I hope this video has helped your understanding of fluids.